All right, this is Honors Algebra 2 Pre-Calc. We're in the Chapter 6 / Partial Fractions unit, but we do 2.7 from the book in this unit. So 2.7 is partial fraction decomposition. So in example 1, we're going to set up the PF decomp, or partial fraction decomposition, for 5x plus 11 over an x squared plus 5x plus 4. So if you recall, the very first rule of doing partial fraction decomposition is to fully factor the denominator. So in this case, it's going to factor into an x plus 4 times an x plus 1, right? So when I set up my decomposition, what I want to do on the other side, right? So over here, so this is my original, right? Over here, I want to do my setup, right? So I want to set up my partial fractions decomposition. And when I do that, right, what that's going to look like is that each one of these factors is going to get its own fraction. But what I'm going to do is put because both of these are linear divisors, right? So each one of these is linear, right? This is linear. It's an x to the first power. This is linear. So the x plus 4 is going to get its own fraction where it's on the bottom, and so is the x plus 1, right? They each get their own fraction, and it's a sum of those fractions. Because x plus 4 is linear, I'm going to put a constant numerator, right? And because x plus 1 is also linear, I'm going to put a constant numerator. So that's it, right? That's the setup. So that's we're actually going to call that A, because just setting things up is a little bit simple. So my setup is really just going to be that this is an A on top of an x plus 4 plus a B on top of an x plus 1. That's the end of my setup. I did my job, okay? So when we talk about doing this, the next steps after we get better at this setup, we're going to go through and actually find the values of A and B. Now, if you don't want to use A and B, you could use C and D, or you could use your initials as long as your initial doesn't have an X, because we already used X. I would avoid using lowercase L's. I'd avoid using O's. I think my S's look like 5s, so I try not to use S. Whew, excuse me. So, another question that comes up a lot is people worry about which fractions first. Remember that multiplication is commutative, so which factor you put first is really just a style thing, or like what occurred to your brain first. So it's arbitrary whether I put the x plus 1 fraction first or the x plus 4 fraction first. It's also arbitrary which letters over which. So if you had A on top of this one and B on top of it, that's fine. In the end, when we are finding the values for A and B, we should all end up with the same numerical value for the thing on top of x plus 1. The thing I called B might be the thing you called C or J or Q, who cares? But the number that I get for B, which is on top of x plus 1, should be the same number that you get for whatever is on top of x plus 1. And same for the x plus 4. Okay, so let's do a B, where it's the same concept, right? So let's do a 3 over, let's do, I'm going to go ahead and put an x cubed plus a 2x, okay? So the first thing I'm going to do is fully factor the denominator. Well, this denominator has a GCF. It has a GCF of x, and when I pull that out, I'm left with an x squared plus 2. Well, x is a linear factor, but x squared plus 2 is a quadratic factor that's not going to clean up, right? So when I write my decomposition setup, the x gets its own fraction, so does the x squared plus 2. Because the x is linear, it's going to get a letter, just a letter. It's going to get a constant, so I'm going to use A. Because the x squared plus 2 is quadratic, it's going to get a linear numerator, so I'm going to use bx plus c. Again, you don't have to use A, B, C in that way, but whatever you pick, they need to not be the same letter, so I can't use A again. Now, I could use A again here because this was a different problem. But in the same problem, you can't use the same letter twice. And again, you can pick whatever letters you want as long as they're letters that aren't already in play in some other way in the problem, right? So that's my part B. Now let's do a C for the setup real quick, and I'm going to angle slightly better because I think you can't see the bottom. So let's do a C. Let's do I'm going to give you one that's already factored, right? So let's do an x plus 2 to the third times, well, we'll be a little fancy, x squared plus 5. Okay, so seems to me that there are going to be 4 fractions, and here's why. This is already factored. This is a linear factor, right? The x plus 2 is linear, but it's a linear factor that repeats, right? And this guy is a quadratic factor. I can't do anything else to factor him. So what's going to happen is when I have a linear fraction that repeats, or a linear factor rather that repeats, each x plus 2 is going to get its own fraction up to that power of 3. So x plus 2 to the first is going to get a fraction, plus x plus 2 quantity to the second is going to get a fraction, plus x plus 2 quantity to the third is going to get a fraction. All of those take care of my x plus 2 to the third. And then my last fraction is that x squared plus 5, which is going to get a fraction. All three of these, the factors are physically linear, so I'm going to go ahead and use an a for a constant, a b for a constant, and a c for a constant. And then x squared plus 5, as we've seen before, is quadratic, so I'm going to use a dx plus e. Okay, now I would say that certainly example A is one that we can and will do together when we're actually solving. I put some thought into example A and it'll turn out nice. I did not put a lot of thought into B and C when I made them up because I just kind of threw in numbers in there. But also B is not a terrible one to solve with only 3 unknowns, A, B, and C. I would argue that C is really pretty tough to solve and is probably a situation where you would be asked to set it up but not actually find the numerical solutions.